Good afternoon. I am Phyllis Wise, and I'm the interim president, and I'm really honored to welcome all of you here for this wonderful series sponsored by the Computer Science and Engineering Department of distinguished speakers. And I can see we literally have people in the rafters today. So it's great that you're all here. I can say that the University of Washington would not be what it is were it not for the great partnership with Microsoft. I also believe that Microsoft benefits from some of our most wonderful graduates, not only in CSE, but predominantly from this department, but from many other corners of the university. It is because of these kinds of partnerships that we consider ourselves the Silicon Valley of the Pacific Northwest, where partnerships between the private sector and public universities create such synergies that could not happen were it not for a healthy environment and a healthy business environment. So today I'm really pleased to be able to welcome Steve Ballmer, currently the CEO of Microsoft, a really hard-charging, demanding, wonderful leader who also apparently is pretty funny, so I want to see that part of you also. And to have a great conversation with our one and only Ed Lazowska, the Bill and Melinda Gates Endowed Chair of Computer Science Engineering. So thank you, Steve. Thank you, Ed. Yeah, thank you.
Well, thanks to President Wise for welcoming all of us here today. It's great to have you here. What I thought I'd do is just get us going by setting the stage. And Steve, maybe you could talk a bit about all the businesses Microsoft is in. You know, we used to think about it as Windows and then Windows and Office and then Windows and Office and SQL Server and things, but it's much more diverse now. Why don't you just give us the picture?
Yeah, I would characterize what we're trying to do in probably 6 or 7 areas. We're trying to build core software and do core hardware design across the devices that power small, medium, and large screen. Small screen, you can think about a phone. Maybe is a good example of a small screen.
Show us the phone, Steve.
This is my phone, a Microsoft Windows phone.
Coincidentally enough.
Yeah, surprise, surprise, the new Windows Phone 7. I gotta make sure my email's not out from Microsoft. But phone, PC, you can think PC, slate, but middle-sized screen is a good way to think about that. And then large screen, think TV, or in some industrial settings, I think you can think kind of wall board or digital whiteboard, et cetera. But small, medium, and large screen. And the key areas of importance there are what are we doing with the user interface? How do you transform the way programs are built for those devices? And how do we think about the user interface and scenarios continuing to evolve across all 3 of those device types? Number 2, we're certainly centered in productivity and how do we help people use technology to be more productive and to communicate better, particularly from a sort of a professional or student perspective. I see a lot of people with pencils and paper. I see a lot of people with laptops. I see some people with competitive product. I see some people with cameras. I see some people with phones. And yet I don't think we've all hit the sweet spot in terms of, even in a room like this, how we transform the productivity process, or how we transform productivity when it comes time to doing research on the internet. I think there's still a lot of room for innovation. Entertainment, we've made a big investment in entertainment as a set of content and experiences, not to the exclusion of everybody else, but when you think about something like our Halo product, we're trying to plumb the depth of entertainment. Search, big area of investment for us. And then last but not least, what do the platforms and tools look like on the back end that are used to build up data centers and applications and the global cloud, and how do you build and deploy applications to those kinds of environments, and how do they relate to these smart devices? And that's broad. On the other hand, it's not as broad as I would say the average person in the world thinks, but it's also sort of coherent, if you will, relative to itself, and there's plenty of space out there for us, we got competitors, we got partners. We're all scrambling in a very dynamic business.
So you got a services business, right? How large is that, and who are the customers? I mean, we think of IBM as being a company that really made a big transition to services.
Yeah, the word services couldn't be any vaguer in the year 2010. In the computer industry, the legacy use of the word of services is a bunch of human beings who you bill out essentially for time and materials. And if you're really good, you can figure out how to not make it seem like time and materials, and you can mark it up a lot. And that's kind of the legacy view of services, and we do some of that. Truth be told, we probably have over 10,000 people out of our 90,000 who are involved in services of that kind. And they're pretty important if you want to get your products really adopted, particularly with IT departments in companies of any size. The modern use of the word services is you run a bunch of computers that do a lot of things and sit out in the internet, and you're kind of operating them and building the software for them and then charging people by the drink, whatever the drink means. There's a lot of ways to buy drinks in this world. And that, I would say, is the modern use of the word services / cloud. In that sense, you know, in this very auditorium, in fact, I had a chance to talk about some of the things we're doing in the cloud with our Windows Azure product, with Office, with SQL Azure, Bing, etc. So both kinds of services we're in, but our growth as a company will come in, let me call them modern services, despite the fact that human services remain quite important to us.
Got it. So I'm going to talk a bit about competition and innovation, both. I had a discussion a couple months ago with Craig Mundy, and he was describing a set of areas where Microsoft had really been first by a mile, and many of these I was familiar with. You know, it really was the first big-time smartphone, right? It was the first tablet. Chuck Thacker and Butler Lamson and all did a tablet PC prototype, gosh, a decade ago. It was the first, let's say, interactive home TV and entertainment. I remember Craig came to Microsoft to work on that project. Rob Short, sitting in the audience here, was working on that. There are a set of other areas, digital music players, right? The first digital music players were Rios. They were Windows things. And those are a set of areas where the company was the innovator, but in truth, somebody else managed to make a really big play. You must think about this all the time. You got an explanation for it? Got a plan for it?
Sure. I mean, there are plenty of areas where we've gone first and have clear success. There are plenty of areas where we've gone first and now have an ongoing opportunity for success. And there's plenty of areas where we didn't go first and had success and didn't go first and are wallowing in that fact. Okay? So you get kind of all categories. And probably the lesson to be learned, or the reminder for anybody sitting in the audience is, in a sense, success in a commercial sense or success in an adoption sense actually requires doing a lot of things right. Innovation is important, invention is important, but getting the delivery model, hardware, software, service is also important. Getting the brand proposition right is important. Getting the delivery, doing things at the right time, on the right kind of technology base, hardware, software. And we've got, you know, cases that went brilliantly. We've got cases that we're working on. There's no other category in our life.
Got it. Okay, so let's talk a little more about innovation and sort of the R&D in the company and Microsoft Research. We have lots of engagement with MSR here. There are 20-some MSR people on our affiliate faculty, for example, just in this department, and lots in math and linguistics and stuff. You folks invest $9 to $10 billion a year in R&D, and it's always seemed to me that among the modern IT companies, you're almost unique in the amount of that's looking out more than one product cycle, right? That is, MSR is probably close to 1,000 headcount now worldwide. It's just a great research organization, and almost nobody else is doing anything like that. You know, you look at a Cisco, we always say their R&D is M&A, for example, okay? So there's this huge contribution being made. One challenge, of course, is appropriating that benefit for the company, and there have been some real successes. I mean, Kinect's an example. Maybe you could talk about Kinect a bit and how it came to be, and more generally, how you sort of manage the R&D investment.
Look, can I do a little market research? I talk about Kinect, and Ed will talk about Kinect like people know what it is. Show of hands, how many people kind of know what the word Kinect means to, and how many people have actually even have seen a demonstration of a real like machine? Okay, so about half. Kinect's really quite remarkable. It's a sensor that goes with the Xbox. It sits on your TV. It's got microphones and cameras in it and has the ability to do recognition of your voice, and it has the ability to do recognition of your body, your face, your gestures, and to let you, as we say, be the controller for what goes on your TV set. And the whole notion of the technologies, whether it's voice recognition or vision or some of the other important technologies that were essential to making Kinect happen, really got pioneered in our research group. They weren't being worked on in any one of our product development groups. And then about 3 years ago, in part for good competitive reasons and in part for good innovation reasons, the folks who were working on Xbox went to the research guys and said, hey, look, we need a different way to have people interact basically in their living rooms with technology. What do you think? And they proposed a number of the ideas, and that's when research meets product development and great things happen. And on November 10th, we'll ship a product to market that I think people are going to find very interesting, very innovative, not just from a gaming perspective, but really for turning the TV into an even broader kind of family entertainment center. I've seen it in my own house. Anecdotes are a bad thing to base business judgments on, but I have 3 boys and 1 wife, and 1 wife who thought that the Xbox used to be the thing that distracted the 3 boys from homework, therefore needed to live in the basement where kind of bad things live. And now with the Kinect and with the set of entertainment experiences, whether it's the ability to for her to control it and watch this series Modern Family that we've all kind of fallen in love with in our family, or some of the new, call them games, the beach volleyball, some of the other games, they are very different in terms of being physical and active and not necessarily with the same kind of shooting that people associate with kind of video games traditionally, and you get a whole different kind of experience. But based upon stuff that just couldn't happen at Microsoft without this fundamental research that we have been doing in MSR, the Microsoft Research Group.
Yeah, a lot of that research isn't as externally visible. I'm doing a federal report, spent the whole summer slogging through this, but a piece of that points out that Microsoft has really made more progress in the last 10 years on software quality than anybody else. And that's Amitabh and Laris and Schulte, those folks who've just done a phenomenal job of both sort of research and engineering of that research into things that really change the reliability of software in important ways. Bad news is, as Fred Brooks said years ago, there's no silver bullet there. You just have to kind of keep pushing the rock uphill. We have these.
No, but having tools that help, let me say, mortals and rocket scientists alike write programs that are provably of higher quality, have fewer vulnerabilities. I mean, that's all goodness. That's part of the keys to the path for the whole world to create more of the software that's going to be required to kind of bring alive a lot of the scenarios we talk about, whether it's in, quote, the technology business or in the ways technology will be used in a variety of other businesses.
So you talk about natural user interface these days, and I honestly don't know what you mean by that. Could you explain what that means?
Yeah, the word natural user, probably another word that everybody gets a chance to define themselves, but to me natural means natural. The way people want to interact with things. You could say at its time, there was a big advance 20, 25 years ago when we went from what was a sort of a set of block characters to a world that looked like our desk and someplace, a way to point, which was the mouse, and it was natural at the time. Natural at this time is not what natural was at that time. And today we think about machines that recognize our voice systems that we can touch and interact with physically or gesture to, like the Kinect system. One of the areas I consider in the same bucket, which is I think very important, is the ability to express yourself in your own language and have the computer try to understand your intent and take appropriate action. You know, the sort of what I would call version 0 of that, it's kind of the search engine. You can type in any garbage you want, and the search engines will do their best to give you something that it thinks is relevant. And it's not deterministic, it's very statistical, but people appreciate taking a chance. Now the truth is, most of the time you probably don't just want back a bunch of links and websites, you actually want the computer to do something for you. Produce a chart that shows me GDP by country with private debt as a percentage of GDP, plot that for me. I ought to be able to type that in and have something do a reasonable attempt at putting it together for me. And that's not going to happen in the next 12 months, but certainly that would be a more natural way to do things than anything I do in any application today or in any search engine today. It goes from user intent to action with some model and knowledge of what's going on in the world. That'd be pretty good. So I would call that natural.
Ever since MASH, we've all wanted our own Radar O'Reilly, right? We just haven't quite got there yet. So
I got to remind you, I don't think we have a lot of Radar O'Reilly fans in this audience.
come on.
That would be our generation.
Here's my question. How many of you know who Radar O'Reilly is? Oh, thank you.
Yeah, you got about 20%. But anyway, keep working it.
All right. So let's talk about consumer versus enterprise, right? You know, I think that the sort of standard thing to say is that there was a time when IBM was the enterprise company and Microsoft was the consumer company. And Microsoft is obviously big in both enterprise and consumer now, but one could caricature Apple as the consumer company and Microsoft as the enterprise company. And I wonder if it's hard to combine those two. You know, Xbox was, in some sense, done by a pretty separate division. It had a different culture than lots of the rest of the company. How do you blend those two? Are they different or not?
Well, let me say it this way. There really are two different kinds of skills, and it's not really consumer and enterprise. I think that is the way everybody talks about it, so I agree with that about that. But the real question is, do you build things for people as people, or are you building things for IT people and developers? And you could build for one or the other or both, and those are really kind of more separate. The guy who builds a router probably doesn't have to build a piece, sort of a PC experience or a phone or a slate. You just build the router. And you can be reasonably abstracted from what's going on with people. The guy who builds a router is going to be tempted to build storage, is going to be tempted to build servers. Why? Because things are getting transformed so that the very way in which we build data centers and servers and program them, you'll think more about storage, networking, and compute all at the same time. So there's a natural filling, but there's a boundary there you don't have to cross. If you build things that like people want to use, people just really want to use them. They don't want to use them when they're like in their work and then go learn a whole separate set of things at home. They're going to use them spanning their lives. I'm sure very few, maybe no one in this audience, carries two phones, one for work purposes and one for personal purposes. So it's hard to draw any distinction to me. So if you build things for people, you're going to build things for people in their enterprise or work persona and in their consumer persona. And that's true of us and the guys we compete with. I don't really see that as any different. And yet, if you build things for the back room, you can stay in the back room. We happen to do both, but we're going to be consumer persona and enterprise persona. But once we built an operating system, it turns out you want to be both places. All of our operating system competitors historically have been on servers and on devices. And, you know, in a sense, you could say the descendants of Unix current all have that attribute even today.
But if you have if you recognize, let's say, Microsoft Office as a corporate asset, and it unquestionably is, then it's natural to think that it will be an asset on the phone. And so the phone ought to run Word. And it'll be an asset on the game box, so the game box ought to run Word. And that's not necessarily a bad thing, but it may not be what sells phones or game boxes.
Well, if you get confused about what's most important, shame on you. The truth of the matter is I'm really glad that this thing runs PowerPoint. I bring presentations with me. If I want to make an edit or two, I can make them. I'm really happy about that. Do I think that it's the only thing? And if this just runs PowerPoint better and better and better, we're going to sell all the phones in the world? That's probably insufficient. On the other hand, will we capture some people who are happy about that because they use this in their work persona? When they leave for a trip, they know they can put all the notes and slides they're going to present and trip backgrounders and carry them on their phone, which if you happen to be on the go all the time, it doesn't matter what you're talking about, Slate or anything else, you want something you can just jam in your pocket, then I think this is kind of an important concept. So the question is, how confused do you let yourself get? Not, is it fundamentally an okay thing to do?
Got it, yeah. So let me ask one more question before turning it over to these folks. I'm interested in what it's like operating as internationally as Microsoft does. It seems to me, again, that it's an area that the company's been really successful. You seem to have had fewer visible missteps in China, for example, than certain other companies have. And it must take a lot of forethought when you're dealing with human rights issues, with intellectual property issues, with things like that. How much effort of sort of what I'll call non-technical effort do you devote to that strategy, and how do you achieve success in all those nations?
Well, let me say that we have the benefit/luxury of having grown up as a company kind of in the information era. There's something self-referential about that. But that actually means that we've grown up global from the get-go. Most industries that are not global grew up not global either because the world wasn't a very global place. It wasn't connected. It wasn't flat, so to speak. Or things required a lot of capital investment to be in multiple parts of the world. And therefore, you'd have guys who build cars separately in Europe than they'd build them in the US. And, food tastes are obviously not exactly global by and large because that's a legacy business that's grown up for many years. We grew up global. And what that really means is, how do you design products? It's not like the world has historical tastes that are different. Russian people, Indian people, German people, and American people are all happy to share information. They don't have dramatically different needs. They do have a need to be able to express in their own language and blah, 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 blah. Some of the things that we see now have more locality to them than they used to. Maps, for example, you could say it's a global technology, and yet it requires local data. You have to have whatever the appropriate set of information is, you've got to have in every locality in which you want to offer your product. And it turns out that's not cheap and easy. If you want to digitize the Russian landscape, that's pretty expensive, as big as Russia is, and therefore different set of issues. But it's not because it's Russia versus the U.S. It's just the sort of the value of the data could be kind of less. The third issue you get into is some populations do have a different set of demographic characteristics than Western populations. The percentage of people in Western Europe and the U.S. who are affluent is really, in the grand scheme of the world's population, quite high. You can argue what it is, but it is quite high. If you take a look in Africa or India or China, you would find a much lower percentage of people who are really affluent. And then you get into a product design problem about how do you take these technologies which are globally appealing and yet make them affordable for people who really, really don't exist. We just don't have that much in the way of real rural poor in the United States as you would see in some of these countries. That's an issue. Then you get into what I'll call the political issues that you talked about, which show up in some countries. China's kind of most celebrated on this because it's the biggest and kind of most dynamic marketplace. But the truth of the matter is, we've had some of these geopolitical issues even amongst developed countries for many, many years. And how do you deal with them? With finesse. Sometimes you do, sometimes you don't, but that's kind of got to be the principle. And then last but not least, intellectual property protection is very important to us. Most countries are quite good about that. There is a big problem that intellectual property is much less well protected in the largest market in the world other than the US, which is China. And we haven't solved that problem. This year there'll be about as many personal computers sold in China as the US, and our revenue will be, a 20th, something like that, 15th, 20th, something. So, and our market share is actually probably a little higher on balance in China because you could say most Chinese people think our price is lower.
Got it, good. So let's take some questions from you folks. There are 2 microphones, one over there, and let's say that at least at the start, if you know who Radar O'Reilly was, you shouldn't get up and ask a question, all right? So let's focus on students, at least in the beginning. And the one other ground rule is please avoid sort of long, elaborate statements. Let's ask questions and get reactions from Steve.
Hi, thank you very much for coming. My name is Robert. I'm a student at the business school here. This summer I worked for IBM and I did a lot of work on the Smarter Planet project to see how IT can make our civilization more sustainable. Can you talk about how Microsoft used this opportunity?
Yeah, I think it's a phenomenal opportunity in a variety of different ways. And I'll give 2 or 3, some that we're intimate with and some that I understand and think are important. Perhaps the most important issue in terms of sustainability of the planet actually is better science. We need kind of better energy science and environmental science, because the truth of the matter is, a lot of people should also be concerned about the number of people around the planet who live in poverty. And one of the keys of bringing people who are in poverty today out of poverty is actually will involve the consumption of more energy. And so, despite our best efforts to save in the developed market, the world probably in its progression will want to use more energy. So the question is, how do we speed up the science that makes that energy green, clean, not bad, if not good for the environment? And that means faster science, faster science, faster science. The ability to model the physical world in the virtual world and then run fast experiments probably will do more to speed up scientific exploration in this area and many others than almost anything over the next 20, 30, 40 years. We've seen that already in some of the pharmaceutical and biomedicine areas. We see that happening certainly even in things like oil exploration. I mean, with all the problems the world has, carbon-based fuels are going to be important for a while. We want people able to find, explore, be safe in their extraction of those things, and the ability to simulate and model the world's crust, if you will, is already an important aspect of speed in that area. So how do you get more green? You get better science that lets you be more green, and one of the big ways to do that is with these new computing techniques, high-performance computing techniques and modeling tools that let you model the physical world in the virtual world. That's one. We're working on a set of tools essentially to help scientists build better, faster models and a set of infrastructure that allows that to be managed and deployed, results shared. We have a project with the U sharing oceanographic. It's on our Azure platform, and basically everything else was done here at the U. But for oceanographers to share oceanographic data, scientists don't share for a lot of reasons, but one of the reasons is it's just darn hard to share it. And the project that the U's done in this area uses some infrastructure from us, and I think really arms the oceanographer, I'm no oceanographic expert, in some new ways. Number two, it turns out that the IT industry itself, or IT products, are a growing part of the use of energy in today's world, whether it's data centers or the charging of computers and phones, and all of that is actually material. And the efforts that we and the guys we partner and compete with make to reduce that footprint is very important. I was here about 6 months ago, probably now, and we had outside a next generation data center. Well, this next generation data center comes in a shipping container. It's literally got the equivalent of thousands of servers in it. You plug in the electricity, but the first generation used to have to plug in a fire hose to cool it down. The generation we had here 6 months ago, you plug in a garden hose, just to give you a way to think about the reductions that have been made in the consumption of power in these devices. Third relates to the hardware, and you can get a real recycling problem, and certainly for the hardware we do, which right now I'd say focuses around the Xbox, thinking through how to make that more recyclable, more green, better materials is an important part of what we're doing.
Over here.
Good afternoon. I'm Jimmy. I'm a grad student in the EE department here. And my question, I've actually asked this question to Steve Jobs as well, so I'm imagining it's going to be quite a bit coming from you, quite a bit different. It's basically, what, in your opinion, is the value of academia and academic research? So research that may never produce a product, besides just pumping out future employees for Microsoft.
That's a good one. Look, it's a little bit like the value of venture capital. You want to have people that are trying a wide variety of things under a wide variety of, quote, business models, where research actually is a business model. The projects tend to be very different than you would see in a big company or a startup or any place else. They're smaller in general, they're more self-contained, they have a different horizon. The work product is as much the publication and the contribution to general learning as it is the specific outcome. And that's got a place in advancing kind of the state of the art and what we get to use. And a lot of the seminal innovations will come out of academic style research, whether it's done at a place like Microsoft through our research division, or at the U, or a variety of other places. So I think it's quite important. And of course, we know research universities don't work very well unless you get the feedback loop between teaching and research. That's also fundamental. And so as teaching institutions, this place doesn't work as well if it doesn't have a healthy research agenda. So I see a lot of different kind of a set of benefits. And getting into some cosmic discussion about what's important or how you prioritize, the world seems to do that reasonably well. Guys like Ed will always say, hey, look, the kinds of stuff we do should probably get a little bit more of the kind of expenditure levels of society at large, and I'll say bravo, advocate for it. And Microsoft certainly is as active as anybody in promoting and welcoming and helping to fund that. But the world's always trying to find that balance between what I'll call the shorter term and longer term investment. And somehow in aggregate, this country and the world seems to have done a pretty good job of scientific and innovation advances. So I see an important place for academic research.
Thank you.
Did I give a lot different answer than the other guy?
I think you basically said it wasn't what Apple does. So I think you probably like it a little bit better.
Good. We like that.
So it seems like Microsoft might have a harder time recruiting new employees than other companies. For example, I've heard that Microsoft spends 10 times as much recruiting an employee as Apple does. And I know when companies come here and talk to us, other companies have made a much more compelling argument as to the challenges of the things that they're working on as opposed to Microsoft. And I was just wondering if you thought that might be a problem and if you had any potential solutions.
Well, getting the best and the brightest people is an important thing that we all do. I think we do a pretty good job at it. And I don't particularly think it costs us I mean, the data I've seen wouldn't say it costs us any more than it costs anybody else on the planet. We work hard at it. We may even overdo it because we want to make sure we're always seeing the best and the brightest. You know, when we go up to bat against other great companies, we win. There's nobody we don't win over 50% of the people that we offer in common. Okay, nobody. Name your favorite one of our competitors. We win over 50% on joint offers. You know, what's got to be my fear? I got to make sure that there's nobody we're not offering who should have gotten an offer. That I'm always thinking about. But you know, the people where it's jump ball, we'll win some, we'll lose some. You win and lose people for a lot of different reasons. I think on balance, the quality of the work, that is the kind of interest level and the excitement level, the chance to do interesting stuff, we're right up there with anybody on the planet. You know, things do go in cycles. If I think back, I started the recruiting program at Microsoft when I joined. The first thing I did was start university recruiting.
He was our recruiter.
Yeah, I used to be the recruiter who came to the U. In 1980, we started. And, you know, the competition, you know, Oracle was the key competitor for a while. Now they don't really show up much on campus. You know, Apple's a great competitor, but has been less active in college recruiting. You know, Facebook's fluxed up, and, you know, who was the guy? Trilogy. For a while, it was Trilogy. A company in Austin was the hot place to go work off of campus. The thing I think we've done, if nothing else, has been very consistent in our message. We want the best and the brightest off of university campuses. And, you know, this year I think we hired, we had an intern program. It was about 1,200 people. We hired 1,200 people out of campus, you know, at least on the computer science side. That would include research as well as development, undergraduates, masters, and PhDs. And I'll stack up the folks we hired against anybody. One of the key issues is we got to make sure we're hiring the best and brightest, not just in the U.S., but across the world. The U.S. education system helps to the degree it can attract people, the best and brightest from outside the U.S. to the U.S., but we still have to work hard also to make sure we're getting our fair share, particularly in China and India. 25% of the world's computer science graduates come in China now. 25% of the world's computer science graduates come in India, and 50% in the other parts of the world. So it's a particular importance to tap into that talent pool.
So here are the statistics from here, just for people's interest. And again, it's always cyclic. You know, somebody has the buzz one year, somebody else has the buzz another year. It kind of comes and goes. But every year in recent years, we've sent about 30 bachelor students from computer science and engineering here to Microsoft, which is more than any other company. That's just sort of 30, 30, 30 like clockwork. This past summer, there were, 50. I think, there were 41 technical interns, 50 overall, but 41 from this department. 18 of them were women, actually, at Microsoft for the summer, and there were another 18 at Microsoft Research as summer interns. So you're our biggest recruiter consistently year after year after year. And that doesn't mean that...
You get to work on Kinect and phones and new versions of Windows. And, you know, geez, some of you even like technical stuff. You can work on that kind of compiler and backend. I mean, we have a diversity of work, which I think is part of the appeal.
Course, once again. Anyway, it's been pretty successful.
Great.
Other questions? Got someone back here? Yeah, go ahead.
Thank you.
Good afternoon. My name is Krishna, and I'm a first-year MBA student. My question is, in your opinion, what would be the next big revolution in technology?
Yeah, I think depending on how, let me give you sort of an umbrella statement to that, and then I'll break it into a few pieces, because otherwise it sounds too monomaniacal to make any sense. The cloud. But the cloud for me is a broad umbrella. It's an umbrella that encompasses new architectures that are fundamentally more efficient for the way we build and deploy applications. Oh, and by the way, the business models that are associated with those. The cloud really does, when you think about using the internet, so now let me not call it the cloud, but you use the internet in new ways, and we can really do this mapping of what's going on in the world and our ability to glean knowledge about that with users and what they're interested in, what their intent is, it's a different world. And you couldn't dream about that in the old world of the internet. You certainly couldn't dream about it without the internet. But this user intent, user knowledge mapping thing, I think is hugely important. And it is cloud enabled. When you say that, I think we should think about data and people. You know, you could say, oh, we've tapped that out, we got social networking. And yet the number of cases in which you want to bring people together, find and bring people together in new and interesting ways, I think there's still a long way to go. Let's say you have a family member who's sick with a certain disease, and you really want to talk to the people who've gone through the treatment of that disease. Well, if you're lucky, maybe there's a group on X, Y, or Z, and maybe you find it. But the ability to find and connect, not only with the information that's interesting to you, but also the people, I think there's a lot of opportunity to innovate. And again, the cloud is the backdrop for that. Natural user interface. The truth of the matter is, a lot of the things that we want to do and should do and can do in user interface, you really can only think about when you have a two-way connection with the user. So a piece of software that's sitting on a device that is isolated can't learn, can't get smarter, can't improve. If we don't recognize your face one time, will we recognize it the next time? Well, the best way to make sure we're getting better is to have a feedback loop between these user interfaces and the cloud so that we can continuously improve. I think that's an important dimension. So natural user interface, user intent and global knowledge, understanding and mapping, new, more productive ways to write and deploy applications. I'd put them all out there, and they are propellants for entertainment, science, productivity. They're kind of more architectural in nature, and they're all enabled by this fundamental change to a cloud-based world with smart devices talking to it.
You've probably seen the report 5 years ago called Rising Above the Gathering Storm. It was a National Academies study that raised a set of cautions about, for example, education and research investment in this country. And just a month ago, they came out with a new version of the report, sort of 5 years later. The start of this report is 3 pages of pretty frightening statistics. For example, in K-12 about the likelihood that you get taught science by a teacher who has any training in science. In research, the fact that the federal expenditure on research in the physical sciences and engineering is actually down by 50% as a percentage of gross domestic product over the past 20 years or something like this. And I wonder, as upbeat as you always try to be and I try to be, there are these sort of concerns on the horizon about our level of investment, our education system, disparities, and what's your overall sense if you were president of the nation instead of CEO of Microsoft? What would be on your mind in these areas?
Look, many good things in life start with education, and the fact that there's even a debate about the quality of the U.S. educational system. I think it's more than a debate, but the fact that there's even a debate should cause us all to be alarmed and ask, why, what would we do differently, and let's do it. Not what should we do differently, but let's make something happen. I think it's a complex topic. It's not a topic I happen to be expert in. It is a topic that, I've probably learned more from just chatting with Bill Gates than I have anything else, because it's a topic he spends a good part of his life on. But it is as mission critical as anything that I think our country and other countries, but we live here, that our country has to deal with. And I'm not sure what the answers are, but I'm glad there's smart people working on it, and I would make it job one. Absolutely job one as a policy agenda, because whether it's social welfare, this, that, and the other thing, education is one of the few, what do they call them, tides that lift all boats.
Yep. Question here.
Sure. You spoke earlier about the difference between being in the situation of creating a product that's first on the scene versus catching up and entering in a marketplace. How do you, as an established company, determine the right appropriation of resources between focusing on products that are essentially competing products versus focusing on creating products that are actually aiming to be the first on the scene, so to speak, that aren't directly competing with an existing service or product?
Carefully. Now, everything's a set of judgments. You know, in a sense, the ability to sort of not only see what might happen, but time things correctly and have enough agility and fluidity in the way you're able to assign resources. It is not true that everybody who's good at writing compilers is good at creating the next generation of user interface for Xbox. So I wouldn't say we have 100% fluidity even in our ability to sort of switch things around on a dime. People build expertise, and you know, we have to decide when to go build new expertise, what expertise to build, then get with a given expertise, how much do you put into listening and responding to the kinds of things that people know they want versus, you know, trying to skate ahead, as they say in hockey, to where the puck will be. And, you know, there's not a science to that. There's not like a formula that says spend X percent or Y percent. And when we do it well, great things have happened for us. And when we don't stitch it, you know, quite together, you can be early or you can be later, but you don't quite get the same outcome. And that's one of the things that's got to be mixed into the system. The advantage startups would have over all of us bigger companies is most of them actually go bankrupt. So in aggregate, nobody worries about any one of them, and each one of them will try something with great fervor. And if it falls apart, it falls apart. Bigger companies don't, by and large, invest like that, whether it's us or the guys we compete with. If you take a look, most things we compete with were either created relatively deliberately, or at least by the time they got to market, they looked deliberate, or they weren't all that successful, or they came from a startup. Facebook came from a startup. You know, the things when we compete with Apple, those are relatively deliberate decisions. They make decisions like us. Google tends to throw a lot more things against the wall, so to speak, and yet the things that are really strong for them weren't done that way. It was the things that, the two startup things, YouTube on the one hand and the search engine. Our enterprise customers, you can't do that at all. Turns out if you want to make an enterprise customer mad, ship them something and pull support for it in 3 years. You have to be a lot more deliberate. So there's no science about that. You just kind of have to wrap your mind around it and think it through.
Hey, I'm Will, and you guys have mentioned a fair amount about cloud computing as well as even some mutterings of like smart grid technology. And I was wondering what changes you foresee in the future in security industry, or what Microsoft's doing in security to perhaps protect those resources, protect those platforms, and what you might have to say on that.
Well, we make a big investment in everything we do, trying to be more and more secure. I mean, security does have what they call the good guy, bad guy problem. Good guys have to be right every time. The bad guys only got to be right one time. So we and all of the other good guys are all, you know, doing our best. And part of what you have to be able to do is be good. Partly you've got to be able to put on belts and suspenders, so to speak. So if one part's bad, the other part's not. The guys who build our Windows Azure service, I feel like every time I run into them, they're saying we're up to 8 layers of protection. And in a sense, that's at least the right mentality to have in terms of how you think about this stuff. It's only going to get more important, I would say, as we use information technology in a wider range of devices. I think there's an interesting, I don't think it is helpful to sort of the state of well-being of society, but there was really interesting research that Ed and Hank and what was the name of the fellow who we talked to?
Yoshi Kono.
Yeah, Yoshi Kono here at the U got me even more thinking about what we and others need to do to continue to invest in security.
Question over here.
My name is Jens from Dublin, Ireland. If you had a wish list of technological breakthroughs, let's say outside software, what would be your number one item? I mean, to kind of make your Microsoft dreams come true.
I guess you mean if it's out of software, it must be hardware?
Hardware, energy, supply, or whatever.
Yeah, I'd probably focus in on hardware. And I think the areas in which there will be important advances are power and miniaturization, where there's already been a lot of good stuff done, but more will happen. And those technologies need to not only go into compute and storage, but we got to ask what the changes will look like, particularly in output, but also in input. I mean, this is a small screen device, but this is the size device I want to have in my pocket. So the question is, how can this be a large screen device while still fitting in my pocket? I'd like to get there. There are a lot of actually promising technologies on the horizon. Where does it go? How do we get there? I think those types of things enable a lot of new scenarios that could be pretty exciting.
Let's take one last question.
From the radar generation.
Good.
Looking back in you've had this great opportunity. You've seen Microsoft develop from the beginning. Looking back over your experience, what technology development was unexpected and delighted you, and what first comes to mind?
Unexpected and delighted me. Usually unexpected and delighted don't go together for me.
Well, let's say surprising.
Well, I think it's probably fair to say that probably the most important thing to say is most of the things that were surprising actually had as much to do with the way the business developed as the technology itself. The notion that you would want to search and find things that are important to you, nothing was surprising. The way, our competitor Google came together with a business model around that, probably I would say surprising. At least we didn't get in gear quite at the speed that with 2020 hindsight, we would have liked to, and I think we've talked about that. But it's sort of the innovations that bring together a technical advance with a business advance that I think almost always wind up most intriguing. The microprocessor industry wasn't just about computers and the innovation of low-cost microprocessors. It was also a re-stratification of the industry from integrated to less integrated. The transition, when we look at it, say, from 20 years ago, when PCs went from being all about the front end to also being servers, was as much about a business model for how a PC server would get sold. The innovation that's happened around smartphone has been around hardware and software and business model, where you get the subsidization of the phone by the operator being a key part of what's allowed these things to really explode. It was important before the smartphone. It's been essential in the world of the smartphone that there's been business and technology innovation that accompanied each other. So the surprise, not always delightful, but when we're doing it to somebody else, it's delightful. When it's being done to us, less delightful. The surprise has almost always come around the combination of the probably technical advances that were easier to see and business model advances that were maybe a little even harder to see.
Steve, let me ask you one last question. You've got 3 kids. What's the advice you give them? They're going through school, aside from do your homework.
Yeah, no, that would be the number one right there. But, in some senses, particularly at university, I think most of what you're trying to do is find something you can get real pumped about, get energetic, get fired up, get passionate. It doesn't really matter all that much what. If you find something you can get passionate about, great things will happen as you pursue it over the course of your life. Something productive. I'm sure there are plenty of things to get passionate about that are just social and friendly. But find something you can pour your heart, body, and soul into that you really want to work on, that you want to let your mind wander over. And everybody's kind of a little different. I happen to be a little bit kind of a energetic, outgoing, blah, blah, blah. Some people are quiet, but you could see the fire and passion about what they're talking about in their eyes. But really having something that you love, that you can throw yourself into, I've got a freshman in college, I've got a high schooler, and I've got an middle schooler. And I would say in various forms, that's kind of what we wind up spending time on. And homework kind of is an enabler, so you get a chance to not be restricted in pursuing your passion, because it is a form of achievement which everybody's going to get measured on and is going to give opportunities. But you can be really good at that part and never find anything to get pumped up about. I got plenty of people I knew in school who were brilliant but never found anything to get excited about. That's not the way you want to go either. So you want to be able to do both. And if you get excited about an academic area, that's great. I didn't get excited in college about an academic area, actually. I got excited about many extracurricular areas. I was a football team manager. I was the ad sales manager for the newspaper. I was publisher for the literary magazine. I found lots of things to get really excited about. And thank goodness I also did well enough academically to stay in school, get into graduate school, that kind of good stuff. But my passion developed outside of a particular academic field. But I sort of, the good fortune I'd wish all of you is the chance to find something that you really want to throw yourself into, heart, body, and soul.
Thanks for being here, and Steve, thank you so much.